Good morning to everybody. My name is Lucia Petti, and I'm one of the organizers of this school in the frame of the project PulseCon. I will start with a general introduction of our project to let you have an idea of what we are doing. And let's start from the partnership that we have, project scope and composition. This project has been funded by the European Commission, and it's based on a partnership of partners coming from Italy, from France, and from Poland. We have institutional partners like ENEA or UGA, CNR, National Council of Research in Italy, and INFLPR from Romania. And then we have companies like CBRTP, like Cedra Technologies, CTEC, and also Aiming Company and Cytex from Romania. Now, it's a FET project, and the main topic of this project is based on a new type, on the realization of a new type of piezo-electric actuators, which can be controlled by light, and which are based on the use of low-cost photomobile films, whose movement can be induced and controlled either by sunlight or by artificial light. So the idea is to create, in the frame of this project, a new class of photoactivable devices that can potentially change a sort of, somehow, the paradigms of a field which can be considered the field of piezo-phototronics. And the idea is to create also innovative devices based on the use of these materials. This project has been funded with 2,980,000 almost €1,000. And to go to the main objectives of of our project, our main objective is to study, simulate, fabricate, and characterize actuators, sensors, and harvesters, which can be driven by light, operating in ultraviolet, visible, and near-infrared range of light. And in order to realize devices with specific different industrial goals. We have identified mostly 4 research targets. And these targets are to investigate relevant materials and design properties. And this is important in order to realize which we think can be the suitable photomobile polymer layers and piezo composite layer in order to achieve our project aims. Second target is to identify which can be radically new solutions and strategies in order to couple the 2 different layers, which is the PMP layer and the piezo composite layer. Third target is to fabricate and demonstrate an innovative light-driven actuator, what we call the PMP PZL device. And the final target is to integrate our light-driven actuator in optoelectronic systems for very advanced industrial implementation. We started this project by the submission and the approval of a patent, and the title of this patent is the Energy Conversion Device and Production Method. And this patent was initially submitted by the CNR, INEA, and UGA, and can be considered, let's say, the brick of the whole project. Just to give you an idea of let's say, how it works, our material and our idea, I mean, objectives and principle, working principle of our device. So, as I said before, what we want to do is to develop optical switches and innovative mechanisms where the deformation of these materials can be easily controlled by intensity of the incident light. Now, we have a device which is made of two parts. We have a PMP photomobile polymer, and we have the piezo layer. The PMP is the part which is the part of the material which is sensible to the light, while the piezoelectric composite layer is the part addressing the sensing functions. What we have is that with the incident light, we have a light induces a movement to the photomobile substrate. And thanks to this movement, we have that the piezoelectric layer generates an electrical signal. And then a reverse electrical signal is generated by the piezo layer when the light is off. And when the light is off, the substrate comes back to its initial position. Just to give you an idea of what can be the innovation, well, the novelties of our project compared to let's say, to the photomobile state of the art, we can say that in our case, as far as photomobile devices based on polymers is concerned, we have different benefits, like reduction of cost of fabrication, like the possibility to make greener systems, and also the idea to make them plasmonically active, for example. As far as the piezoelectric onto flexible substrate is concerned, well, innovation of our project based on for example, design and modeling, which are going to take into account multi-physics, testing of new techniques of growth of zinc oxide nanowires, for example. Also, well, the testing part, validation of modeling trends through different characterizations. And finally, it's very important the combination of the photomobile and of the piezo materials. In this, the novelty that we target addresses different applications, and it is the realization of an opto-switch and opto-valve system, the realization of reconfigurable optical systems, and the realization of a photo energy harvesting systems. So just to conclude this introduction to our project, the different technologies are covered in the frame of our PulseCom project. Technologies involving somehow combining piezoelectricity, photomobile excitation, and semiconductors. And both of these are basis of piezotronic. We combine also optoelectronics, and we are moving towards, let's say, a new field, which is the field of piezo phototronics. That is a combination of piezoelectricity, semiconductors, and photo excitation. So I stop here. Just this was just to give you an idea of the FET project. The FET project is funding this summer school. Now, what we are going to face in these 2 days. Part of our lectures will be very close to the topics, research topics that we are facing in our project, and part will be closely related.